Good evening. The ones who have already arrived, apparently there are a bit of numbers are trickling in. Although we are a bit late, I think we'll just go ahead and continue with our today's event. We were waiting for others to join us and to give us whether to go ahead and what to do. But today, I think let us just go ahead with what we wanted to do today. And probably it will be okay if we all take it the way we had planned. Perfect. Let me take you through what we had planned for today, and I hope the sound is clear. If it's not clear, kindly make use of the question and Q&A section to be able to show your concern, and always keep us updated on what is happening. If you're not getting us, kindly let us know what is happening on your side. I'm not able to find out clearly what you are getting, so kindly let us know through the Q&A and even the chat session in case you are interested in chatting directly to us. Perfect. I think we need to go on, and today we will be talking about, we're taking you to the, again, another event for Arduino, and this is lesson 4, the fourth event. The fourth lesson for Arduino, and we are going a bit step by step because we are hoping that people have done a lot. And today we want to really look at what we are talking about generally on the inputs and outputs. In Arduino, of course, we talked about the board receiving inputs, and then the same board is able to, some of the pins to become outputs. Some pins can become inputs so that they receive signals, and some pins becomes output as they output some signals, or they actually renders the action that is required. So in most cases, it's required, and therefore you'll find that an Arduino is busy analyzing that information that's getting in, interpreting it, and then moving it out so that something happens. In fact, it is when things happen, that's when we can be able to say that Arduino is having something, or our program is working, or our project is now delivering some bit of an outcome or an expected outcome in that particular session. So kindly, I hope this one becomes the next big space that we can be talking about. Great. I think now, of course, we talked about, last week we talked about sensors and actuators. We just introduced, we took you through so that you see some of the sensors that come with the Arduino kit. Today we want to go a little bit deeper and touch on the sensors. Probably if we get time, we'll be able to do a bit of coding. But if not, it's usually very, very prudent that we understand the sensor itself. What does it do? What are they? So when we talk about sensors and actuators with Arduino, sensors are definitely the input. Remember, we talked about inputs and output signals. So the sensors are those gadgets or modules that are responsible for acquiring or be able to capturing some signals or data that is taken into Arduino, and then this data is analyzed or interpreted or used for the sake of doing an action. And whatever takes out to go and do that action is now what we're calling the actuators. This one would be things like the motion, probably we talked about maybe for the movement, we need things like, I think we talked about some other modules. I think the drivers for the rotational, the feet to rotate and stuff like that. I think we'll be talking about that. The motors and all that. These are the actuators, the ones that are doing something. Ones probably you have already gotten the sensor. Probably you're sensing maybe it is hot. What should I do? I move away. Definitely the motor will take that signal and translate it and put it into movement. Now that is what is called the actuator. The sensors and the actuators. The sensors are specifically for the sake of capturing the data. Then the actuators are the ones that take that data and put it into action. And a very good example of a sensor here, we're talking about sound sensor. We're talking about probably temperature sensor. We talked about things to do with the iEARN sensor, and we are going to show you just even one or two so that we move through. I'll just take you through and then we'll see. And then the actuators, things like the motor, and we had several motors. Remember last week, we talked about the different kind of motors that are available and how we can be able to use them. Great. I think maybe it is good to now start with this kind of a simple diagram that shows you how particularly we are going to connect. This is also part of our next activity. How do we connect the different modules or different things we have, or different parts of Arduino? How do we make them connected so that things start happening? I think for this, we're just showing a little bit of an output based on the LED, the red LED that we have there. But this is just how first I want you to know that very soon we'll be doing all that ourselves. How do we show a connection? How do we show some sort of a way how the wires and the connection and the way the algorithms will take place, so that at least whatever thing we are planning to happen, it will happen using the various ways that I think these are just diagrammatic or graphical representation of some of the projects we will be running very soon. But I'm begging so that at least I can take you back a bit, just a bit, so that before we come back to this particular space we have been talking about. And I wanted to start with this. Let's talk briefly about the sensors that we have here, especially in these ones are the basic ones that come with the kit, the basic kit, the standard Arduino kit. And one of them that is very, very obvious is the ultrasound distance sensor. It's called ultrasound distance sensor because, as we are going to look at it, when do we use this? Because those are some of the questions that you keep asking. When do I use this kind of sensor, and how does it work? So I think maybe it's only good to first of all learn how it works, then before thinking about how you use it, so that way you only use what you understand well. So this is how it looks like, and I think maybe in the video we can always look at how it looks like. I'll be showing you how it looks like, a real one on our table here, so that you are able to see that it is something that is doable, and you can be able to see it from here. Great. Great. So probably, we will be able to show that briefly, how it is working and what we do. But otherwise, this is basically what we're talking about, the ultrasound distance. So how does ultrasound distance work? The sensor, distance sensor. And so this is how basically it is. It has two parts, the T and the R. So even if you have if you look at it generally, you'll see that probably let me work on the camera, because the camera is not working. So for the audio, I think we're okay. And then for the camera, the microphone also, I think, yes, the microphone is okay. We'll use that. And then for the camera, let us use this, so that at least I show you some of the things we're seeing on the ground here. So we are talking about ultrasound, and this is how an ultrasound looks like. I want you to see it from the camera here. This is how an ultrasound looks like, and you can see it is just a small thing that like looks. Probably you can see our something like a robot that is actually moving, and in front of it you can be able to see these two eyes. These two eyes, they look like an eye. This is the sensor we're talking about. It's called ultrasound sensor, and the ultrasound sensor is what we're going to talk about, what actually it does. It has two parts, the T and the R. Maybe you are not able to see that from that picture because it is not big enough, but I'm going to look for probably maybe something closer. This is it. And if you look at it, it has two eyes. One side is written probably, basically, you may not be able to see this, but if you look closely, one of the eyes is written as T, and the other one is having the letter R on it. So it means something. These two small things that look like eyes. This kind of sensor is what we are calling the ultrasound sensor. So why is it having two parts? One written R and the other part written T. That is what we want to look at. Maybe I can stop the video so that we use the other whatever. So just let us send that. Let us continue so that you're able to see the different parts. So one part is T and the other part is written R in the ultrasound sensor. And the T here is for transmitting, and R is for receiving. Remember, it's about transmission and receiving. So how does this sensor work? What is the role of the sensor and what actually it does? And in which kind of project can we be able to use this sensor effectively? That's why we wanted today we talk about the sensors specifically. Because there's a possibility you may want to do a project where an ultrasound sensor is required. So how does it work? That is what we want you to see today. So the ultrasound sensor works this way. Okay, I think maybe I've just shown you one. It throws, it sends, it transmits with a T. The I, the other, the second I, which is the T. I mean, you can find that part of the gadget, part of the it looks like an eye of a cat. The first time I started looking at the sensor, I would say, this eye of a cat, or the eye of the robot. Sometimes you may mistake it to mean the eye of the robot, but actually, what we're talking about, those particular parts, one is a transmitting eye. Let me use the word eye locally for the people to be able to understand. And the other one is the R for receiving. So what is this that it transmits and receives? And we say it transmits some signals. It just transmits random signal to target some kind of probably, let me say this is, let me put a pen and then I show you. So these are the signals being transmitted. So it transmits them just randomly as they go out there, and you can see the way the waves as they go until they meet. This is an obstacle. Maybe it is some kind of thing stopping it. So once it knows there's an obstacle on the way, definitely it now, what happens when they get these waves get to the obstacle? They are reflected back. Remember, they were all moving towards this side, and then all of a sudden now again they are supposed to be going back. As they go back, the amount of time they take to reach back to this particular, because remember this is the one, the T is the one that transmits, is like the one that lets out those waves, and then the R receives the echo, is like the echo of that wave. The wave has been thrown, then it reaches the obstacle, and then it bounces back. As it bounces back, that is what we are talking about. The receiver now here receives those waves or the signal, and is able to calculate to know the distance between this particular object and the obstacle, which is here. The obstacle, we talked about the obstacle here. So that is how the optical, I mean the sensor work. This sensor of we talked about being two eyes or stuff like that, work exactly like that. And let us go a little bit further and see. Actually, probably you may not be able to see, but so what I'm talking about is that we want to see the same waves coming back. So you can see the receiver, there's a microphone, the R, getting the point. The T is the transmitter. and it now is like, it acts like the loudspeaker. It's the one that really releases the waves or the sound. It has a transmitter. It is more of a loudspeaker, and you can see it here. And then the receiver, which is the microphone, because as this one moves, because the sound goes direct and reaches at a particular angle, reaching the obstacle. So this is the obstacle. Maybe it's the wall, maybe it's a human being standing on the way, maybe it's a roadblock or stuff like that. Think about all of your projects and see which one works in which particular area and how do we use them. And then once the sound, as you can see, the sound is, once it is released, it travels again along the, as you see, these cables are able to show you. So the loudspeaker sends it. Once it reaches the obstacle here, now it doesn't again move. This is like an obstacle. It can be a wall or something that really cannot allow the sound to move. So instead, it goes back. So once it goes back, it's reflected back. It echoes back and it's received by the microphone, which is now the R. Remember, we talked about the T and the R. These are areas you can look at that particular thing and you'll see they are written T and R. And I think maybe this is very elaborate so that you can understand that that is how whatever thing you've ever seen like this kind of sensor works to determine, to be able to detect the distance before, or rather the proximity of an object from the other. Probably can say this is 10 meters away, 15 meters away, 30 meters away, and actually this particular sensor is able to detect up to around 30 meters away. And how do we know the difference, the distance? You calculate the distance based on the time delay. As the transmitter transmits the loud or the sound or whatever, then the receiver picks that. Now the time between the time when the receiver, or rather the echo, is reaching back to the receiver, is actually reaching the receiver, that time delay is what is calculated into the distance. Maybe that one is again another thing we can be talking about. But generally, I think we are very much on the same. When we get this sensor, this is how we can connect it, and you can see in many aspects that there is something I want to. This is how we connect it to the board. This is, of course, there's no doubt about how what the Arduino. Of course, the Arduino board is here, so the question can be how do we connect it to the Arduino? And I think that's why this diagram is very important. You can see that this is the sensor we are talking about, and the T, I talked about the T that transmits the sound, and we talked about the R. The other side is usually the R that receives the echoes that bounces back to the sensor. So as it receives, then we are able to identify the distance between the object and the sensor, whatever the obstacle it is. And this is how we connect it. And I think you can see that I want you to know that the sensor has 4 terminals, or four pins. That one is written ground, and all this you can find the information basically on the sensor itself, the sound sensor itself. So you can see it says ground, the G and D. You'll find that other one is that the pin is for ground, the pin for echo. This is a pin that really is very important because it's the one we want to find out what is it doing in most cases, and that's why we're putting it to pin 13. And then we have pin the timing, that is called triggering, the triggering pin. The triggering, that's the one that, like the microphone, that's the one that sends the signal. It's called the trigger, TRG. You can see there, TRG. And then we have the power, the VCC. V is V, maybe voltage in. So that one we'll have to put it to the voltage, which is like the power, 5 volts. And then we connect the triggering to any of the pin. I think the triggering in this particular sense, it has been connected to the 8th pin, and then the echo is connected to the pin number 13. And then there's ground, which is again also connected to the ground. So you can see that all of this is actually how we connect this kind of sensor to the Arduino for us to start using it. Remember, we talked about it measuring specifically the distance between an object to whatever it is. Probably, maybe, I don't know whether you can take time, look around, and maybe can I give like 2 minutes so that we try to find questions that are around this, in case somebody has a question around this particular sensor, so that if we go from here, we can now connect and look at what actually happens once it's connected, how do we use it, and stuff like that. So I think maybe this is very key. Let me just give a short break to find out from the colleague, because it is like 30 minutes, so definitely there's need for a break. And I want you to ask questions before we go to the next sensor, which I'll also explain. Probably today we may not be able to do the coding itself, but it's good to understand the sensors very, very well. Welcome back. Apparently there are no questions. Probably people are listening or they have missed to come on board. Whatever happens, I think we are there. We will be with you all through. Great. I think maybe now we want to. I think we were talking about this the ultrasound distance sensor. It sends, as we've seen, it sends the sounds, it transmits the sound, and then again waits for the echo. Once the echo comes back, then it calculates the delay that it takes, how long it takes for the echo sound to come back, using the other sensor, or the other terminal written R. It receives that echo, and then that calculation is now taken, that how long does it take for it to reach, for the sound to come back. Once we know how the sound is coming back, definitely we'll now be able to get the distance. So that's why we call it ultrasound distance sensor. I think maybe now this sensor is understood. It has 4 pins. One pin goes to the voltage, as we have seen there. And then we have another pin for triggering. Thank you, Maxwell. I can see you're there. What's the code? Okay, we'll be giving you the code. And for what particularly, again, the question would be, at this particular level, we're just showing you how to connect the sensors, and then we'll now put you through how to do with it. Of course, I'll be giving you the code. Don't worry about that. And then, of course, the echo. This is now when we are talking about waiting for it to come back, and then the ground, as usual, just for the sake of the whatever. So thank you so much for that. Let me just take you to part of the code, as Maxwell has asked. What about the code? So maybe we may not be able to do a whole coding, because that one would mean we want to have this particular sensor and also take you through another sensor, so that when we now sit down to code, we'll be talking something like this. So one, you see, we will define and say the triggering, the trigger pin, and then the echo pin. Remember, we have the T and the R, so that the trigger pin, remember we talked about the trigger pin, which is the T here. This is the one which we have connected to pin number 10. And then the echo pin, which is this one here, we have connected it to pin number 13, if you're able to see. So when we go to the code, it actually shows what we're talking about. So we are telling it, like, look, we are saying there is pin 10 and pin 13. All these ones have been connected. And because the distance can be, we have this, we'll be taking you through the software and giving you the variable types. So this is, we are declaring a variable of float, because the distance cannot be 1, 2, 3, 4. Probably the distance is 1.2, 0.0, or 3.5 kilometers, 3.5 centimeters. All those points, because it is not definitely a whole number, so it's not an integer. So definitely that's why we are saying you have to declare the duration and make sure the variable for the duration, or rather, and the distance can only be float duration, because it can take 5.1 seconds, 6 seconds for the echo to come back. So once the ultrasound releases the sound and then it gets the obstacle, it comes back as a sound back, and then it is received. And remember, when it is received, then we are able to determine what the distance is all about. And then we at the setup, we'll want to see, don't worry about this, because this one can only help you to read, so that you're able to see things from within. And it's very important, of course, because you want to read what is really happening in terms of numbers before you work out and decide whichever number that appears, what you need to do with it. So trigger pin is an output and echo pin is an input. Remember trigger pin, because we are sending the sound out of the ultrasound distance sensor, and the echo pin is because we are receiving. That's why we are declaring it as an input, because we are receiving the sound back. So I think this is just setting up. That's how, these are the most important, the code you need to really look at that. And of course, the serial display is what we are saying. We want this to use just to display within. Maybe we are not at this particular level, we are not going to use much of it. Then, of course, all this will be teaching you when you're getting the Arduino software, which we have not really gotten there. We thought just going straight to the sensors would be good, so that you understand the sensors. And then, of course, when we now start writing, so initially we are thinking that the triggering is low, and then we give it 2 seconds to delay. Then we send. By putting high, it means we are sending now a signal. So that pin of triggering triggers the sound and then gives delays again, wait, and then switches off. So the only thing we want to do is all the time the pin keeps sending and wait for 2 seconds and send and stop sending, again sending. So all this will be repeated time and again. So as it keeps sending, then we start listening. So these are the, and we want to hear the duration where the echo pin will be listening as it keeps speaking, and then look at the distance. Therefore, it's equal to duration divided by 2 times 0.3. This kind of 343 meters per second as speed. We know the speed of sound being there, 300 meters per second. So we want to know the distance. We calculate the distance by getting the duration that takes. Of course, the echo in coming back, divide it by 2 so that we're able to get that. So I think maybe all this will come in good time. So good. I think if there is no question, let me imagine that this kind of the code, it may not help you as per now because it is just showing you what actually takes place within that sensor we talked about, which is the ultrasound distance sensor. Moving fast, let us take, I just wanted maybe to take this webinar to talk about just 2 sensors. We may not be able to cover so many sensors, but 2 sensors. So the next sensor, which again, very important, you may want to use, is called the Pir sensor. In most cases, the common language you're talking about, movement sensor. It is able to get the movement, and you can imagine the way the movement in the room. Probably you want a project where you are taking care so that the thieves don't come in the room. When they get in the room, you're able to trigger the alarm, and you're using only the movement sensor here. And on my table, I think I have the movement sensor. They are of 2 types. I mean, it's only 1 type, of course. I'll be showing you the picture of them, as well as keeping on to talk to you about it. So it's dome-shaped. You'll always see it is dome-shaped. It consists of several lenses. These are lenses. You can see these are small lenses, so that whatever light which is being beamed, these are lenses. It can disperse it, so that they come to be so many tiny infrared. Tiny, that's why we call it IR, infrared. So like tiny infrared, they are moving out. So this cover, this is just but a cover that has lenses, so that whatever light is being thrown, this one now throws it into different direction, because they are small lenses. I'm just the one drawing this. Don't think it's drawn like that on it. So let us see how it looks like, probably more, so that on the table you can see this cover here. This is the cover which we have just removed. This is the cover that has the lenses, but the real thing beneath is just one single beam that comes out. The infrared is beamed from just one single source, but when it reaches the cover, it is dispersed into several, probably millions of the infrared, so that it becomes dispersed all over probably the room, and is able to pick up to almost 5 to even 6 meters away. So you're able to pick whatever movement is taking place around that. And then you can see this, it is placed, the sensor is placed on a board, small board, that has different things. It has a jumper, and then of course it has some little potentiometers that you keep adjusting, maybe for sensitivity, and then probably that other one tells you how much do you need of the distance around it. Then there are several probably capacitors and stuff like other modules attached to it, small ones, just to make a complete movement sensor. For it to become a sensor, because on its own it can still work, because it's supposed to capture, it has to raise the sensitivity and then move the next level. So when you get it like this, kindly don't think it does just appear like this. You can break it into pieces, and that's why you have the cover and you have the underneath whatever gadget itself. So now let us look at many more other things. Maybe let's get to find the pins. How do we connect? When you want to connect, of course, there are the 3 pins. All of it always have 3 pins. Those 3 pins are the ones you will want to use as you connect it to the Arduino board. The pin, there's 1 pin for ground. In the middle, there's the output, and then the voltage comes in the VCC, basically the voltage. This one is what you take straight to the board as you connect it to either 5 volts, because 5 volts is okay for it. Then the output, definitely we want to see maybe, because it's already picking something. So this is what you also connect to one of the pins as the output, because Arduino will want to really get this. It's like you're taking this data to the Arduino using this pin. So this is what you connect to any of the pins in the Arduino, especially the digital pin, so that you use it or program it to do some things. Let us continue naming the parts. I think that's what I want to probably show next. The other parts that I wanted to see is the potentiometer I was talking about. One is basically adjusting the time, the other one adjusting the sensitivity. So that how sensitive do you want the movement sensor to be able to capture the movement? Do you want anything, even like a fly coming by, it can be able to pick? Sometimes you put it, even a rat passing in the room, it's able to detect some movement. But in most cases, it may not be able to pick the rat. So that's the aspect of sensitivity. How sensitive do you want it to really work? That is the aspect here. We are talking about sensitivity. And then the time is, of course, it will keep checking whether there's movement in the room. How often do you want it to keep checking? Because in most cases, it beams and then it again keeps checking the status. Or sometimes you can see there's movement, and then that movement moves away. So it checks and then it finds no movement, therefore it says there's no movement. But if it checks and only finds the movement and then stops at just saying there was movement, then even 5 minutes later you can still think there's still movement, yet movement has not been there. So you have to really ensure the number of times you want it, so the quality of timing, so that it keeps repeating, it keeps checking, especially keeps checking and checking whether there is still movement in that particular space. Remember, it is movement sensor, and it uses IR or infrared, which is beamed and it moves out. So let us continue doing a bit of naming. Then we have the sensor. You can always see some sensors also put on board. Light sensor is also equipped with it. We know a light sensor can also come at a small gadget on its own, but the light sensor here is very important because sometimes you want this movement to work at night. So the light sensor will contribute, will help the movement sensor even operate during night hours, or rather when there's no light, so that the movement sensor is able to work all through. Or probably you just want it to work in the night and not on the day. So those ones are aspects of it that you really need to know. Then the no repeat and repeat, of course, we talked about that in terms of even when I was talking about the time. So how much should it repeat, looking and sensing around and ensuring that there is actual movement in the room, or there's no movement at all. It tries to check on the movement. If there's movement, it says, there's movement. Goes back again to check whether there's movement again. Probably the movement has disappeared, or the person has passed, or it has stopped. In this case, it's very important, especially when you want to turn on and off lights in probably toilets or in the dormitory or in some places where you don't want people to be wasting light. So you are tempted to turn on and off the light. So when you turn on the lights, when somebody has gotten into the bathroom, as he's using the bathroom, the lights are on because of the repeat or no repeat stuff. So they're keeping checking. Is the person still in? Yes, the person is still in. So keep the lights on, keep the lights on. So it keeps checking when the person has left the room. Now it keeps checking again, finds no, there's no person anymore, and therefore there's no movement. There's no movement anymore, or there's no motion inside the room, and therefore what should we do? We should now switch off the light. So it switches off the light because it keeps checking whether there's person. But otherwise, if you just put it on and then there is nothing, it does not repeat, it will only switch on and wait for the time is told. Maybe switch on this for 5 seconds. So after 5 seconds, the light will go off. So you can find yourself inside the bathroom, you're using the bathroom, but the lights have gone off. It's not that there is power fluctuation or whatever. It's the sensor switched off the power because it was not put at, probably it was set to no repeat, and while you needed a repeat. So depending on your project, you'll want to ask yourself whether you need it to repeat or you need it to just no repeat. Because for example, in place of alarm of a thief, definitely you just need a no repeat. Let it just make noise once, and then that one, it's enough to alert the police to come over to be able to do or to alert the neighborhood. But imagine a situation where it keeps on making noise and noise and noise, probably the whole day, and even when the police people are coming in, it keeps making noise. So at that particular level, definitely, it is now not giving you the result that you needed. That's where the repeat and no repeat work. So again, I want to say this one is basically dependent on your project. What do you want to do? What do you want to come up with? And I think that is very important to know, to note, and maybe we can go straight and try now to connect it to the Arduino board and see how do we connect it. As I've said, the output, this is the one that will be sending the signal of whether there's movement or no movement to the board. I was trying to create a simple project here, just a very simple one, where we want to see whether if it's detected, this LED will light up. But this one shows that the detection is ready. The infrared are already been dispersed in the room, and then this one will wait after probably triggering the movement. It waits again maybe for some time. That's how maybe using that maybe using the LED may not really give you the real picture on how motion sensor works. But I think for me, just because I wanted to detect how it's working, how it's doing some stuff, this would be a very equivalent thing. So start imagining, where do you think you can use this kind of sensor in your project? What will it be censoring or sensing the movement at what particular level? And you can see the way connecting it to the Arduino is so simple. One, just remember the VCC, which is usually the one that takes the voltage. Is connected to 5 volts. Remember, it can pick to. Remember, there's something I want to. Let me take you back to this, and then you can be able to see. I talked about this VCC. Remember here, when talked about the VCC, probably you can see down here. This is what I'm talking about. Look at the kind of power it can be able to receive. Remember, this is so powerful. It may not. It can even use 20 volts. Which is big enough. It means, therefore, that's why it is used even in the toilets and stuff like that, because it can pick big power. So you don't need really. Of course, in your project, kindly don't go to real electricity because it may not really be safe for you. But this one is a strong sensor. Tells you it can be used in a real world project. You don't need to say, I'm just going to try something or rather to prototype. But you can come up with a project that is working. We have seen in many schools where you go toilets and probably the boarding sections, they are all now using movement sensors. And you can now, even you in your project, don't fear using the sensor in a real world project because it can take quite a lot of power. Although in our case here, we've just managed to use it, we have connected it to 5 volts. Instead of connecting it to probably a bigger voltage. But just to tell you that it can pick. Then ground, of course, goes to ground. So you see, already the connection is very simple that you can be able just to connect. Anybody can connect this to the Arduino. Then the next would just be, again, as Mwalimu Maxwell has just noted, is about the coding. So the coding, again, becomes your part. And I want you to see LED. Maybe we may be looking at the LED in the next level, because the LED has the leg. There's a leg which is short, the other leg is usually long. The leg which is long is usually like the positive, the one that really has to receive the one that's taken to put on the pins. And remember, I said all the pins are emitting 5 volts. It's not very sure how big that can be, but LED cannot receive 5 volts. 5 volts from the Arduino can automatically burn them or destroy them or short circuit them. Sometimes you may want to see whichever language you are getting. It depends on each subject. If you are a physics student, you can really give it a physical or technical term. So for those students who are not taking some of those technical subjects geared towards electricity, you can just say this one would destroy it. And that's why we need a resistor. So you can see we have put a resistor to protect each and every LED. You may want to ask why this resistor along the way. So you see this, the power is coming like this and moving the red, look at the red LED, but somewhere along the line we have to put in the resistor just to protect it from burning, because we know the power will be leaving, not coming from LED. But remember, once this one has detected and takes the communication through pin 7 here, once the movement sensor detects and brings in the communication that, hey, there's somebody in the room, take care. What happens is that now in the process, the Arduino now sends by sending signals, and most of this goes in form of the voltage. It's like power, sending power. So if you're sending signals to this LED, it should not be able to burn the LED, and that's why in the middle you're having resistors. I think maybe this is something we will talk about in the other section, where what is the work of the resistance and the ohms and all that. I think maybe we'll talk about this. We want to run away from theory as much as possible so that we go to practical. But because of time, we wanted just today to take advantage, look at just for 2 sensors. Maybe there are other sensors, like even I'm having sound sensor here or microphone sensor, which you can use by clapping and the lights go on, clapping and the light goes on. I think next time we'll be talking about, we'll now be coding just that light sensor. Maybe we'll just take 1 sensor. In our next program, we are taking only 1 sensor and doing a practical coding with it on the table here and ensuring that it works as far what we are learning today about sensors are. Maybe the time is running, and I want to just take you to how the code may look like in the sensor, in the movement sensor, maybe to detect. And all these LEDs, those are now integers. Don't worry about the LEDs, which is one is put on. This one will light if there is movement detected in the room. Pin 13 will be able to light. Ready LED is supposed to show us that it's now ready to detect, and then wait LED will be put like that. Then the motion sensor is connected to pin 7. I think the PIR here is just the infrared, or rather the motion we are just trying to put. So once we have declared or defined how we have connected, remember this, when we talk about defining, making definitions, sometimes we talk about variables. But what we're trying to say, in this particular section, we are declaring, we are already showing Arduino what to tell it what we are saying. First, we are saying we are going to use pin 13. We're also going to use pin 12. We're also going to use pin 11 to connect something like this. So it's like we're keeping some value here. Probably it is very necessary, of course, but if you don't understand, again, we'll take you through this in the next session. So, and I've said now in setting up, this becomes an output. I think all these things we will be able to talk about. So this is actually how the movement sensor, this is what it uses. And I put a delay of 60,000, like almost almost 6 seconds to be able to get that working. After 6 seconds, it should be able to again detect movement in the room and things like that, and then show us that it's ready, and then probably waiting can be turned off, because the wait for 6 seconds and then again do. So it keeps repeating to detect. So as soon as it picks, that's where we are now coming to the last, where we are saying, okay, get value from motion sensor, of course, and then what does it do with the value? I think maybe then triggering anything, whether it's an alarm or something like that. So maybe because of time, I'll just rush and say, probably that is how the connection will be naturally, but all in all, I think it is good for the day. And mostly we've learned about 2 sensors today. We've learned about the movement sensor or the motion sensor and the ultrasound sensor and how they work and probably how to connect them. In the next lesson, we will learn, and not only learn, we'll only take 1 sensor. Apparently, we are now seeing it is very hard to cover a sensor and then you fix it yourself on the table here, and then until it works within that particular time. So definitely next time you're only going to take 1 sensor, and that one will be, I'm promising you, it will be about the sound sensor. And we'll now work on a project where you clap and the light turns on. Imagine you are inside a room and you're clapping and the lights are turning on, and then you're clapping again and the lights are turning off. So something like that. That's what we want to work on. We have different sensors here, but we'll only pick 1 so that we work with in our next project. Otherwise, I think I'm very, very happy for today. Thank you so much. Keep asking questions. The Q&A section is open for everybody. Kindly use it to ask questions. Thank you very much for being with us today. The videos of this, the recording of this particular training will be taken, will be downloaded, and in fact we'll put on YouTube, and the link will be sent so that you keep reading more about this, because it's very important you learn more about this as you go on your own. Thank you very much, and thank you so much, Maxwell and team, for listening and for being part of this. And it doesn't matter, we can always have a meeting of 1-to-1 with the team to be able to help them. Thank you so much. God bless.